Hi there. So for today we're gonna do our hands-on lab part 3, multivariable linear regression, and we're gonna do 4 tests here. And the first one will be predict the price of the car with respect to the horsepower of 120, car width of 70, and car length of 180. So for the first part, we import pandas, SPD, numpy as NP, and then sklearn import the linear model. So we have df here. Df, I'll read the CSV df dot head. Let's try just 10 columns and rows here. So this is the data, and as you can see, we're gonna check first if there's any null values, and there is none, fortunately none. And next we're gonna go with the linear regression. If we're the coefficients first, horsepower, car width, and car length, those are 3 of the price, since we're predicting the price. So the coefficients, we're just car price, car width, car length, yeah, car. So the coefficients over here, it's 109, 113, and 81. The intercept was 45, and if we predict the numbers 120, 70, 180 respectively, horsepower, car width, and car length, we get 20,162. So that's our prediction value. And then we go over to the price of the car. We're using the price formula of A times the coefficient plus B times the other coefficient, and so on and so forth. So our values is here horsepower, 7, car width, and car length. Then we have the price of the coefficients, 109 times the horsepower, this 1138 times the car width, 81 times the car length, minus the intercept. It's supposed to be negative 81,369 since we're using this data, minus this one, and then it's 19,492. So it's somewhat close to the prediction. Yeah, it's 20, so it's somewhat close. So that's number 1. We can predict that car price. And the next is we have to create a 3D plot of linear regression model of the relationship of the CT-MPG to the curve weight and horsepower. First and foremost, we have to see the coefficient, the intercept, and if we can predict it. Array is supposed to be 35, but using the formula, horsepower 111, 70. This is taken from the data, by the way. So our horsepower might be 111, curve weight is 70. So using the price formula, we could formulate this CT-MPG, horsepower, curve weight of negative 45. It's unfortunately negative, so the prediction isn't similar or almost similar. But if you plot it here, this is the data. So 1,500 curve weight. So the lower the curve weight, the lower the horsepower. So the higher the curve weight, the higher the curve power. So but there's many cars that have lower the curve weight. So if we put it in a plain view, unfortunately this is not interactive because I've tried 3 times. It only crashed the Google Colab, since it's the back end of Google Colab is static. It does not want me to have the figure as interactive, since it crashes the entire section over this section. So I could go over to Jupyter Notebook, but unfortunately I don't know how to have the the CSV in that web page. So we over here we have the function to have the plane. As you can see, we just copy the equation, and we have to arrange 50 to 300. That's the horsepower. Our y and our x is a curve weight, 15,000 to 400. And then this is C. It really has well, the shape is similar, but yeah, the lower the curve weight, the lower the horsepower. And there's many cars that have this type of horsepower and curve weight. So that's number 2. So number 3 is a rather tricky task. I have to model the relationship of the highway MPG to the cylinder number and the car body. Cylinder number and car body are not integers. They're numerical, or they're categorical, I mean. So what I did with this, as you can see, car body is supposed to be this one, strings or categorical numbers, and cylinder number force, and they could have had this as integer, but they did not. So what I did is I have a mask and a condition that if the cylinder number is 4, it will change to an integer. 3 integer, 2, 8, 12, 6, and 5. All of it is exclusive to this column. And same with the car body. So whatever the car body, so I categorize all the car bodies: convertible, sedan, hardtop, hatchback, and wagon. Convertible has the number of 1, sedan has 2, hardtop has 3, hatchback is 4, wagon is 5. So it looks like this. So all of it is categorical integers now. Now we have to correlate it, plot it. So this is the plot. So high MPG, a car body, yeah, there's a correlation. So there's 45 MPG, highway MPG, for example 45, it has 45 here. It has 2 cylinder number, which is sedan, and then a car body of 3.5. Car body of 3. Yeah, car body of 3. So that's the correlation between the highway MPG cylinder number and the car body. And if we put it in the mesh grid right here, so unfortunately it's not interactable, but I put it there just so we can see and number 4 task is there a correlation between the car brand with the same car body and to the price of the car. So this is very tricky. I don't know if this is correct. So this is our data point: car name, car body, and price. So car name, all of it is very we cannot very unique. We cannot have it as similar as this, because since it will take us a long time and very tedious. So what I did was select all the unique cars, and all of that cars will be replaced with the name, the proper name, Nissan Ports Toyota. Yeah, Mazda to Mazda, Nissan to Nissan, all of it is just correcting the names. And then we separate the categorical columns, which is the car name, car body, and separate the price, which is the numerical. So categorical head here, you can have, see, head, car link, yeah, the price, car ID, car width. This is all the numerical columns sustaining the integer values. This is the this is the categorical, all of it sustaining the categorical value, so we separated that. Now we only need the car name and the car body. So the question is there a correlation? So there's two correlations: car body, car name, and the price, the car body and the price. I don't know if there is a correlation within the car name and car body, since it blurs. There's a different type of car body but the same car name. So here is just for measure how many counts of cars to the millions, the numerous cars, the name of cars. It's all unique. That's why it's kind of hard to read. So this is the very much this is the car company name versus the average price. As you can see, the average price is 40,000, and then the lowest could be 1,000 over here. I know that's Toyota. I'm sorry it's hard to read, but that's plenty of cars in the data frame. But here is the car body versus the price. Average price, as you can see, hardtop has plenty, has the has the most expensive price than this hardtop type of cars has the most expensive price next to the convertible type of cars, and then the lowest is the hatchback. So that's in between 15,000 and 10,000. So yes, there's a correlation between the car name and the car body. The car name and the car price. I don't know if there's a correlation between the car name and the car body. So maybe we can do that. Maybe we can do this. So, copy selection. So how many car body, car name, and car body versus car name versus car body type. Oops. Could not convert sedan to numeric. Yeah, you cannot convert. You cannot place how many. You cannot put it into figure, since both of these have like a numeric. So that's that. Thank you for listening, and hope you have a good day and stay safe.